All right, in this lesson, we're going to be graphing rational equations. All right, although graphing calculators are a useful tool to determine the graph of rational functions, it's important that you are able to identify certain characteristics of all rational functions. All right, so the following is what you should be able to identify for a rational function. You should be able to identify any holes in the graph. You should be able to identify the x and the y intercepts. You should be able to identify any vertical, horizontal, or slant asymptotes. So to find what an asymptote is it's the line that the curve approaches as it heads towards infinity, either positive or negative infinity. All right, vertical asymptotes. What you do is you set the factors in the denominator equal to 0 to find the equation of the vertical asymptotes. To find the horizontal asymptotes, you want to divide the numerator and denominator by x to the highest power in the denominator. All right, so if the highest power in the denominator is x to the 4th power, you want to divide the numerator and denominator by x to the 4th power. Since we know that the limit as x approaches infinity of 1 over x, if x continues to get bigger and bigger and bigger, the value for that function is going to continue to get closer and closer to 0. It's never going to get to 0, but it will continue to get closer and closer to 0 as x gets bigger and bigger. All right, so that limit actually approaches 0. It never actually gets to 0, but it keeps getting closer and closer to 0. To find the slant asymptotes or the oblique asymptotes, you want to divide the numerator by the denominator. Now, if the degree of the numerator is greater than the degree of the denominator, then you're going to have a slant asymptote. If the degree of the numerator is smaller than the degree of the denominator, then, or equal to, if it's equal to or smaller than the degree of the denominator, then you're going to have a horizontal asymptote. You're always going to have one or the other, either a slant asymptote or a horizontal asymptote. All right, first example. First thing we want to do is factor the denominator to see if there are any holes. There's nothing to factor in the denominator, so there are no holes. The x-intercept. X-intercept is we find by plugging in 0 for the y or setting the numerator equal to 0. All right, so if we set 0 equal to -3 over x minus 2 minus 2, we get 2 equals -3 over x minus 2, or x equals 1/2. So the x-intercept is going to be 1/2. Y-intercept we find by plugging in 0 for the x's. When we plug in 0 for the x, we get y equals -1/2. And then vertical asymptotes, we're going to set the factors in the denominator equal to 0, so we have a vertical asymptote at x equals 2. And horizontal asymptotes, we're going to divide the numerator and denominator by the highest degree in the denominator, which is x. When we do that, we'll get 0. Anytime you have a number, a constant over x to any power, as x approaches positive infinity, it's going to approach 0. So that numerator, the -5x, -5 over x is going to be 0. And the denominator, x divided by x, is 1. And then we have minus 2 over x is going to be 0. So 0 over 1 is just 0. 0 minus 2 is -2. So there's a horizontal asymptote at y equals -2. And then, since we have a horizontal asymptote, we're not going to have a slant asymptote. And here's what the graph is going to look like. So we've got a vertical asymptote at x equals 2, horizontal asymptote at y equals -2. We have our x and our y intercepts graphed at positive 1/2 and negative 1/2. And then we just fill in the curves. All right, next example. First thing we want to do is factor the numerator and denominator. And I'll make things a little easier for us. Once we have everything all factored, we want to first see if there are any holes. As you can see, the x minus 4s, they cancel in the numerator and denominator, thus creating a hole at x equals 4. Since the x minus 4s, they cancel in the numerator and denominator, there will not be a vertical asymptote at x minus 4. There will instead be a hole in the graph whenever x equals 4. And then the x-intercepts we find by setting the numerator equal to 0. When we set x equal to 0, we get 0. When we set x plus 3 equal to 0, we get -3. All right, and the y-intercept, we want to plug in 0 for all the x's. When we do that, we get 0/4, or y-intercept of 0. Vertical asymptote, we set the factors in the denominator equal to 0. The only factor that we have left is the x minus 2. So when we set that equal to 0, we get x equals 2. Horizontal asymptote, we want to, there is no horizontal asymptote since the degree of the numerator is higher than the degree of the denominator. So there will be a slant asymptote since there's not a horizontal asymptote. To get the slant asymptote, we're going to divide the numerator by the denominator. And our quotient will be the equation of the line that is our slant asymptote. So our slant asymptote is y equals 1/4 x plus 5/4. That is the slant asymptote. And this is what the graph would look like. We've got our slant asymptote, the line y equals 1/4 x plus 5/4. And then notice we have a hole in the graph at x equals 4. We've got our x and y intercepts graphed, and then we just need to fill in the curves from there. Next example, last example, we've got, we need to factor the numerator and denominator. Once we have the numerator and denominator all factored, we want to identify any holes. There's no factors that we can cancel in the numerator and denominator, so there will not be any holes. For the x-intercepts, we set the numerator, the factors in the numerator equal to 0. So we'll have x-intercepts at 1 and at 2. For the y-intercepts, we're going to plug in 0 for all the x's. When we plug in 0 for all the x's, we get a y-intercept at 2/27. Vertical asymptote, set the factors in the denominator equal to 0. And we get vertical asymptotes at x equals 3 and x equals -3 are our two vertical asymptotes. And since the degree of the numerator is lower than the degree of the denominator, we are going to have a horizontal asymptote. The highest degree in the denominator is x to the second power, so we're going to divide the numerator and denominator by x to the second power. That first term, x squared divided by x squared, is just 1. As x approaches infinity, 3x over x squared will become 0. 2 over x squared will also approach 0. -3x squared over x squared is just -3. And then 27 over x squared will just approach 0. So when we simplify all that, we get -1/3. Y equals -1/3 is the equation of the line, the horizontal asymptote. And since we have a horizontal asymptote, we will not have a slant asymptote. And this is what the graph is going to look like. We've got both vertical asymptotes at 3 and -3. We've got the horizontal asymptote at just below the x-axis, and then we have the x and y intercepts graphed. We just fill in the curves from there.